Hello and welcome to another video in the differentiation series for the second year of A-level maths. In this video we're going to be looking at the first of two very important rules for differentiation, the product rule. So where is this important? Well, so far we've been able to differentiate functions like this that you did last year, or even functions like this. This is fine. In previous videos, we've looked at differentiating functions like that. Or functions like this. But what happens if we get a function that looks like this? We can't use the chain rule because what would u equal? There's no way to substitute in another function, another letter, and remove the fact that this is two functions times together. And that's where the product rule comes in, because this is a product of two functions. And that's where this rule, this formula, is really important. Now, there are lots of videos on YouTube or things like My Maths or PowerPoints that you can find on the internet deriving the product rule. I'm not going to do that. I'm just going to show you how to use it. But I need to tell you what it is first. So, if we have two functions times together. Now, both of these functions, for now, are going to be functions of x, but they can be any function. So where u and v are functions. They could just be numbers, but then this whole rule becomes irrelevant. Then, dy by dx is the derivative of v times u plus v times the derivative of u. This rule you must learn. It is not in the formula book. The rule that we're going to look at in the next video, the quotient rule, is in the formula book, so you don't have to learn that. So what we're going to do is we're going to have a look at a few examples to show you how to use the product rule and to lay out your answer. So here's our first example, y equals x squared ln x. Now for the product rule, what function is u and what function is v is irrelevant. You can choose whichever way round you want. So I'm going to say let u equal x squared and v equal ln x. Now remember, our formula is dy by dx is u times dv by dx plus v times du by dx. So we have u and v for this formula. We need the derivatives of each of these. So that's what we're going to do. We're going to differentiate each of these functions. The derivative of x squared we're used to, and the derivative of ln x we've seen in a previous video. Now we've got all four bits there, we can just stick it all in the formula and then simplify. So dy by dx is u times dv by dx plus v times du by dx. As you get more familiar with this, as you get more confident with it, you won't have to write out the formula every time. But if you find that you keep multiplying the wrong things together, this is a very important first step. So we've got u times dv by dx. I've used this dot notation for times just because I've got x's. It can potentially get a little confusing. This is clearly not a decimal point. Plus v times du by dx. I'm going to write it the other way around just to make it look nicer. And then we simplify. So x squared over x is x. And that's our derivative. And that's how you use the product rule. And it's pretty much the same thing every time. So I'm going to write out a few more examples, let you have a go, then go through each of them. So here are the 4 further examples. What I'd like you to do is pause the video. Then what I'll do is I will write down the answers for these, just the answer, so you can check if you've got them right. If you're happy with those, then you can just move on and practice. If not, I'll then go through each of these 4 in detail. So here are the answers to those 4 examples. Check through yours. If you're happy with them, then you can go away and practice. If not, I'm now going to go through each of these on their own. So we've got y equals e to the x, x to the 4. So u is going to be either of them, v is the other one. We differentiate both functions. We get these 2 results here. So remember, e to the x differentiates to e to the x, and then x4 behaves as you should be very familiar with from the first year content. So now, dy by dx is going to be u dv, just writing it the other way around to make it look a little neater, plus v du. Now, if you particularly want to, you can factorize, and depending on your textbook, that it may well just do that. So we can see that both have x cubed and an e to the x in. So we can take that outside a bracket. And we're left with that function. Now, what I would say is this is only really useful to do if you are trying to find stationary points. Okay, because we can now see, oh, it's already factorized when solving this equals 0. It's a lot simpler. So that's the first one. So let's now have a look at the x cubed cos 2x. So this is starting to get into the realm of having to use the chain rule as well as the product rule. So again, we identify our u and v, and we differentiate. If you need a reminder of how to differentiate this stuff, you can go back to the video on trigonometric differentiation. Then dy by dx is u dv plus v du. Now, for this, I'm actually going to do it, for this going through it, I'm actually going to do those in the other way round. Because it's plus in the middle, it doesn't actually matter. Why would I want to do that? Well, I don't like having minuses on the front of my answers, is the only reason. So, I'm going to do v du plus u dv. So, we're going to have 3x squared cos 2x minus 2x cubed sine 2x. Continuing on, this is probably the most difficult one of the examples that I gave you. Because again, it's really using that chain rule within a product rule question. And the thing with this is, you don't get any extra marks for using that nice let u equal sine 3x, so therefore v equals u squared. That kind of thing. you don't get any extra marks for that. So, being able to do this by eye is very important. If you find that very difficult, I would advise rewriting sine squared 3x as this. Sine 3x in brackets squared. It makes differentiating it by eye a little bit more straightforward. So as we've seen in previous videos, e to the 4x is going to differentiate to 4e to the 4x. Sine squared 3x. So we multiply by the power, reduce the power by 1, so it goes to 1, and then times by the derivative of the inside function. So sine 3x differentiates to 3 cos 3x. Tidying this up, we get 6 sine 3x cos 3x. Again, we could tidy that up using double angle formulae, but I'm just not going to bother for this example. Putting it together again, u dv. Again, just rewriting it in an order that looks nicer. Typically, you put numbers first, then the other functions. And you see, this is just a little tidier than writing e to the 4x 6. Just looks weird. So that's u dv plus v du. Again, we could factorize this if we wanted to. We can see we could take out a 2e to the 4x sine 3x. And then we're left with 3 cos 3x plus 2 sine 3x. But again, that's only really useful if you're trying to find stationary points. Last example. U is x squared, v is 3x plus 1 to the 4. Differentiate both. So multiply by the power, reduce the power by 1, times by the derivative of the bracket. And then use the formula. So u dv, again, rewriting it in a slightly neater form, plus v du. And that's the product rule. Typically the easier rule to use, but you do have to remember it. The thing that students find particularly difficult is when do I use which rule, and we'll cover that in another video. But for now, that's the product rule done. The next video will be looking at the quotient rule and how you can identify very easily when to use that one. Thank you for watching.